When you sit in front of a computer, chatting with a conversationalist on the other end of the screen about movies, sharing life insights, or even debating fiercely over a certain viewpoint, can you be sure that the other end of the network cable is not a precision calculating machine, but a human with independent thinking ability? This seemingly ordinary scenario hides the most influential Turing test in the field of artificial intelligence. Unlike complex algorithm models that require code accumulation or high-end robots with physical forms, it uses language dialogue as a bridge to build a key benchmark for judging whether a machine has intelligence between human intelligence and machine intelligence. The birth of the Turing test is closely linked to Alan Turing's life experience and the historical context. Born in London, England in 1912, this genius mathematician showed a keen talent for logic and computation from an early age. In 1950, Turing proposed a groundbreaking solution in his paper Computing Machinery and Intelligence, abandoning the abstract definition of intelligence and instead designing an operable experiment to judge whether a machine has intelligence, which later became the world-famous Turing test. He wrote in the paper, "Instead of arguing about whether machines can think, we should design a test to see if machines can exhibit behavior that is indistinguishable from humans." This idea transformed intelligence from an abstract philosophical concept into an observable and verifiable behavioral judgment, laying an important theoretical foundation for the field of artificial intelligence. The core of the Turing test is a thought experiment called the imitation game, whose rules are simple yet full of speculative nature. It blurs the boundary between humans and machines through language dialogue, thereby judging whether a machine possesses intelligence. The classic scenario of the Turing test is set as follows. Participants. The test involves three parties: the interrogator, a human usually sitting in a room isolated from the other two, communicating through text; responder A human, and responder B, a machine. IA, the artificial intelligence under test. Test process. The interrogator does not know the true identities of A and B, and can only input questions via the keyboard and receive text answers from A and B. The interrogator's task is to judge which responder is human, and which is the machine through dialogue. The machine's task is to imitate human language style and thinking mode to answer questions, treeing to make the interrogator mistakenly believe that it is human. The human responder needs to respond truthfully to help the interrogator make the correct judgment. Judgment standard. If in multiple tests, the interrogator cannot accurately distinguish between the machine and the human, for example, the error rate exceeds censure, then the machine is considered to have passed the Turing test and possesses human-like intelligence. Turing's choice of language. Dialogue as the core of the test is not accidental. Language is an important carrier of human intelligence. It can not only convey information, but also reflect complex intelligent abilities such as logical reasoning, emotional expression, and common sense judgment. During the test, the interrogator may ask various types of questions to test the machine's intelligence level. Only when the machine can continuously show a similar answer logic and language style to humans in these different types of questions can it truly pass the test. This means that the machine can not only process surface information, but also understand the deep meaning behind the language, and even imitate human uncertainty, such as occasional grammatical errors and subjective preference expressions. When Turing proposed the test in 1950, he might not have imagined that more than 70 years later, artificial intelligence would develop to its current level. Machines can write poems, compose music, perform complex scientific calculations, and even surpass humans in some fields. The Turing test is like an eternal beacon guiding the direction of artificial intelligence exploration. It makes us always ask, what is intelligence? How far can machines go? And where is the boundary between humans and machines? These questions may never have ultimate answers, but the process of asking itself promotes the progress of human science and cognition. Today, when we have smooth conversations with ChatGPT, when intelligent assistants understand our voice commands, and when text generated by AI is difficult to distinguish from that written by humans, We are all having a dialogue with Turing across time and space. The test he proposed is not only a technical proposition, but also a reflection on human beings themselves. Our desire to create machines as intelligent as ourselves is essentially exploring the essence of human intelligence and asking who we are and what we can create.